Good afternoon, class. We are looking at Chapter 9, Systems of Equations and Inequalities. Here's Section 9.4, Partial Fractions. So we covered systems of linear equations in 2 variables, in 3 variables, systems of nonlinear equations, and now partial fractions. The objectives are understand the concept of partial fractions, identify the different types of partial fractions, learn and apply techniques to decompose rational expressions into partial fractions, decompose rational functions by partial fraction decomposition. Recall system of linear equations, system of equations, a group of 2 or more equations. They can be solved by graphing, substitution, or addition method. Types of system, a system of 2 linear equations in 2 variables can have 1 solution, no solution, or an infinite number of solutions. Inconsistent system, the system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. We have equal slopes, different y-intercepts. If we solve them, we end up with a contradiction such as 0 equals 7, which indicates there is no solution. It's an inconsistent system. Consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. So in short, if 2 lines have different slopes, they have a point of intersection, and M1 is not equal to M2, results in a consistent system. Consistent system with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. In other words, if you solve for y, they result in the same equation. So M1 equals M2, also B1 equals B2. An identity such as 0 equals 0 indicates the system has an infinite number of solutions. The equations are dependent in this case. Nonlinear system of equations. A nonlinear system of equations is a system of equations in which at least one equation is not linear. That is, one whose graph is not a straight line. So for example, you have a parabola, they may not have a point of intersection, therefore no solution. They may have one point of intersection, therefore one solution, or they may have 2 points of intersection, therefore there are 2 solutions. And now section 9.4, partial fraction or decomposition. We know how to add rational functions. The reverse process is called partial fraction decomposition. Any rational function, a ratio of polynomials, remember the definition of a rational function, can be expressed as a sum of simpler fractions called partial fractions. This process of decomposing a rational function into simpler rational expressions that we can add or subtract to get the original rational expression is known as the partial fraction decomposition. If we want to add these two, and remember subtraction is a form of addition. We take the LCD, which is x minus 1 times x plus 2. And we have 2 times x plus 1 minus 1 times x minus 1. And we will end up with 2x minus x is x, 2 times 2, 4, and plus 1 is 5. So we know how to go from left to right. So this way is called adding or subtracting by LCD, the least common denominator. What if we are given this and we are asked to come up with that. This partial fraction is this reversing the process. Given x plus 5 over x squared plus x minus 2, we want to end up with two simpler fractions, 2 over x minus 1 minus 1 over x plus 2. That's the concept of partial fractions. Methods of partial fractions, f of x over g of x, and it has to be a proper fraction for it to work. Remember, proper fraction is a fraction when the numerator is smaller than the denominator. A proper fraction in the case of a rational function, the degree of the numerator is less than the degree of the denominator. Let x minus r be a linear factor of g of x, the denominator. Suppose that x minus r to the power of m is the highest power of x minus r that divides g of x. Then to this factor, assign the sum of the m partial fractions. Do this for each distinct linear factor of g of x. In other words, a1, some number over x minus r, plus a sub 2, some other number over x minus r squared, all the way to x minus r to the power of m. That's the idea, everybody. Number 2, let x squared plus px plus q be an irreducible quadratic factor of g of x, so that x squared plus p of x plus q has no real roots. Suppose that x squared plus p x plus q to the power of n, power of this factor that divides g of x. And then to this factor assign the sum of n partial fractions as follows. Because this is degree 2, you put a degree 1 in the numerator. a1x plus c1 over x squared plus px plus q. Then for the second degree, we put some other, a sub 2 meaning is different than that, and all the way to n. So you repeat this process, okay? Even when it's irreducible, that means this can't be factored. Number 3, set the original fraction f of x over g of x equal to the sum of all these partial fractions. Clear the resulting equation of fractions and arrange the terms in decreasing powers of x. Equate the coefficients of corresponding powers of x and solve the resulting equations for the undetermined coefficients. This is the process, and it may not make any sense whatsoever without looking at examples, everybody. So that's exactly what we are going to do. We are going to look at examples to make some sense, and we are going to elaborate. This is the synopsis of what needs to be done, but we are going to look at it with a lot more details, everybody. Use partial fraction to decompose. Partial fraction decomposition is used when we have a fraction p of x over q of x, where p and q are polynomials. And the degree of p is less than, and that's the key, less than the degree of q. Note, if the degree of the numerator is larger than the denominator, then performing long division first is the key. So you do long division or even synthetic division if need be. But It has to be proper. That's the concept, everybody. It has to be a proper uh, fraction, in this case, a proper rational function. If it's not, they say long division because a lot of times synthetic divisions cannot be done. So you perform long division. So here's case one. Q of x is a product of distinct, non-repeated linear factors. We talk about the denominator. The denominator is a sub 1 x plus b sub 1, a sub 2 x plus b sub 2, and so on. If that is the case, we write it in this format. A sub 1 over this one, a sub 2 over this one, all the way to a sub k over this. A simple example, class. If you have this one, you write it as a over x minus 2 plus b over x minus 1 in any order. And then when you're done, you should end up with this. This is not done. It's just giving you the answer. So you write it in this format, and then you find the numerators a and b. That's all it says. So that's very straightforward. Let's move on with a couple of examples. First and foremost, we want to use partial fraction to decompose x cubed plus x over x minus. What do we notice? This is not a proper fraction. This is improper fraction. In fact, it's an improper rational function because the degree of the numerator is larger than the degree of the denominator. So degree of the numerator is 3, is larger than the degree of the denominator, which is 1. We first perform the long division. Or in this case, we can do synthetic division. Okay, class? So x cubed plus x the numerator is x cubed plus 0x squared plus 1x, let's put a 1 here, and plus 0. And because we are dividing a by x minus 1, we are going to use 1 for the synthetic division. So it looks like this. So I want to make sure we understand. This is 1, this is 0 as a placeholder, this is 1, and this is 0, and x minus 1 results in 1. So you just bring the 1 down. You multiply this one by 1. So we're going to multiply it by this number. We get 1 with 0 becomes 1. We multiply it again by 1. We get 1 with 1 adds up to 2. We multiply it by 1 again. We get 2, and 0 is 2. Now, the degree of the numerator is 3. The degree of the denominator is 1. So this has degree 3 minus 1 or 2. So this is 1x squared plus 1x plus 2 plus 2 over x minus 1. And there's nothing you have to do. This is As simple as it gets. We are done with that. Okay. So there is no need to do partial fraction. When we do the long division, we end up with the remainder, which is in a simplest format, 2 over x minus 1. Let's try another example. Use partial fraction to decompose x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. What is the process? This is proper. The degree of the numerator is 2. The degree of the denominator is 3. You don't have to worry about it. You don't have to do long division. So what do? You have to factor the denominator. To factor the denominator, first, I'm going to take out the x. So I get x times 2x squared plus 3x minus 2. I'm going to factor this one because this is 2. I get x and 2x. And then I play with negative 2 is the product of 1 and 2, one of them negative. So we end up with x times 2x minus 1 times x plus 2. Notice, this is case 1 because the denominator q of x is a product of distinct, that means non-repeated, linear factors. They are different factors, and they are all linear. They don't repeat. Therefore, this is equal to the numerator over this denominator. So we write it as a over x plus b over 2x minus 1 plus c over x plus 2. That's how we write it, everybody. And I hope everybody is following that and everybody is understanding what this methodology is all about. So factor the denominator, write the denominator in factored form, and according to partial fractions, we should be able to come up with a over x, b over 2x minus 1, and c over x plus 2. So what do? We clear out the denominators by multiplying everything by x times 2x minus 1 times x plus 2. Or you can say you do cross product. Either way, so we want to clear out the denominators. So we are going to multiply both sides by the denominator. Let me use this one. We are going to multiply by x times 2x minus 1 times x plus 2. So what happens to the left side becomes just this. What happens to this one? This would be a times 2x minus 1 times x plus 2. This one would be b plus b times x plus 2. And this one would be c times x times 2x minus 1. I'm assuming nobody has any problem with elementary algebra. Okay, clearing all fractions, clearing all the denominators. Now notice, on purpose, I put 1x squared, 2x, and minus 1 so we can understand what's going to happen to this. The methodology is to collect like terms, and anyone has x squared involved, the coefficient must be 1, x must be 2, and a constant must be negative 1. How do we do that? First, we multiply these two. This is 2x squared minus x, and 4x is plus 3x minus 2. This one is x squared plus 2x. And this one is 2x squared minus x. And now we're going to collect everything involving x squared. I just want you to concentrate on x squared. So x squared, we have A times 2x squared, B times x squared, C times 2x squared, which means x squared times a 2a plus b plus 2c. What about x? Let me use a different color. This one involves x. That means 3ax. This one involves x. That means 2bx. This one involves x. That means minus cx. So that means x times 3a plus 2b minus c. And the rest of it is a constant. So what is the constant here? A times minus 2 minus 2a. This doesn't have a constant. This doesn't have a constant. So anything involving x squared, collect them, involving x, involving the constant. So if this is the coefficient of x squared and the coefficient of x squared is 1, so this expression must be equal 1. If this is the coefficient of x and coefficient of x is 2, this expression must be 2. And minus 2a is a constant, must be minus 1. I hope you see that it's not too bad. This is a system of equation you have to solve. Now, granted, it involves 3, but it's not too bad. And later on, I'll show you an easier way to solve this. So how do we solve this? Just understand that this is really not too bad because the last one is basically telling us what? A is what? Positive 1/2. And then you replace the A here and here, and you solve this system of two equations. I leave it for you to do that. It doesn't take long. Again, you replace it here, this becomes 1. You replace it here, it becomes 3/2. You solve this system, can multiply this one by 2, and these two cancel each other. And you end up with B being 1/5, C being negative 1/10. Okay. I'll discuss the easier process here, and then I'll show you with the next example. So what we do is that we go back to this, replace the A with 1/2, B with 1/5, C with negative 1/10, and we are done. So the original fraction is the same as the same thing with the denominator B is being factored out, and it is decomposed into these three fractions. A over x, 1/2 over x, plus b over 2x minus 1, 1/5 over 2x minus 1, and c over x plus 2 minus 1/10 over x plus 2. Very straightforward, everybody. If you want to change this to negative and keep this as positive, that's fine. Now, some students find this long and tedious. There is an easier way of handling it. Let me quickly show you right here, and then I'll show you the easier way in the next one. When you look at this one, you notice if you choose x to be 1/2, for example, everybody, if you choose x to be 1/2, this expression becomes 0. This expression becomes 0. You put 1/2 here, put 1/2 here, and you find b. On the other hand, if you choose x to be negative 2, this goes away, right? Because makes it 0. This goes away, and then replace the negative 2 for the x here, negative 2x here, and you find c. So there is a way to find it without the system. And I'll go over that in the next example. Okay. In other words, we'll look at this same example and show you almost the same example and show you how that thing works. Something very similar. Use partial fraction to decompose x squared plus 4 over 3x cubed plus 4x squared minus 4x. So the very first thing is to factor the denominator. First and foremost, notice class, I can take the x out, 3x squared plus 4x minus 4. That's the first thing. Very simple. And now, this is 3. This, so you say x times 3x, because this is 3. And then you play with this number. Because this is negative 4, you have no choice but to go with 1 and 4, 2 and 2. But one of them must be negative. Why? Because the product is negative. So you do the trial and error, and you come up with the following answer. So now you have your factors of x plus 2, 3x minus 2. So you're going to write this with the denominator being in factored form, and then a over the first factor x plus b over the second factor 2x. I put the x plus 2 first, and then 3x minus 2. So this is x plus 2, and this is 3x minus 2. This one is x plus 2, 3x minus 2. So this, let me just clean up the mess and rewrite it. Fast, this one is x plus 2. This one is 3x minus 2. All right. So there was a typo there that is taken care of, everybody. I hope everybody's fine with that. So if we multiply both sides by x times x plus 2 times 3x minus 2, we can clear out the denominator. So the left side, everybody, if I multiply by this, the left side comes out as x squared plus 4. This becomes a times x plus 2 times 3x minus 2 plus b times x times 3x minus 2 plus c times these two, x and x plus 2. This is fairly basic. I hope everybody's okay with that. Now, I'm not going to use that system of equations. I want to show you in essence, the easier way out. And how do you know what to choose for x? For example, here, this has x, this has x. If you choose x to be 0, everybody. So where did I get that? This has a factor of x, right? Again, remember, you can't choose x equal to 0, but it doesn't matter here because we want an easy way out. So if you choose x to be 0, this goes to 0, this goes to 0 because it has a factor of x. So 0 squared is 0, plus 4, 8 times 0 plus 2 is 2, 3 times 0 minus 2 is minus 2. So one more time. Plug in 0 here, you get 4. Plug in 0 here, you get 8 times 2 times minus 2. This becomes 0. This becomes 0. So that means minus 4a. Right? And a must be negative 1. I hope you see the easier way, the faster way. Otherwise, you have to multiply these two, and then you have a x squared. You have to multiply these two, you have x squared. You have to multiply these two, you have x squared. You put the coefficients of x squared together, and it must be equal to 1. You do the same thing with the x. The coefficient of x is missing, must be 0, and then the constant. Now, the next thing is notice over here. What happens if I choose x equals minus 2? If I choose x equals minus 2, let's start from here. That's minus 2 squared. That means 4 and 4 is 8. Because it's minus 2, this goes to 0. Everybody, this goes to 0. This goes to 0 because x is minus 2. So I have only this one. B times minus 2. 3 times minus 2 is minus 6, and minus 2 minus 8. So one more time. X equals minus 2 gives us 8 on the left side. X equals minus 2 gets rid of this one. X equals minus 2 gets rid of this one, makes it 0. If you put it into this, you get B times x is negative 2. 3 times negative 2 minus 6, and minus 2 is minus 8. So we have positive 16. B. B becomes 1/2. See how easy we can find those? The last one, notice this one. So you set each parenthesis equal to 0, that gives you the x. So this parenthesis means x is 2/3. If you choose x to be 2/3, this one is 2/3 squared. That gives you 2/3 squared. 4 over 9 plus 4. 4 times 9, 36, and 4, 40 over 9. 40 over 9. X equals 2/3, this goes to 0. X equals to 2/3, this goes to 0. So C times 2/3 times 2/3 plus 2, 2 is 6/3, so it's 8/3. So again, 2/3, quantity squared plus 4 is 40 over 9. And this goes to 0, this goes to 0, this one. Again, I hope everybody understands why it goes to 0, because 3x minus 2, x equals 2/3 is 0. And so the left side is 40 over 9. And the right side is 16c over 9. The right side is 16c over 9. If they have the same denominators, must have the same numerators. So 40 is 16c. So c is 40 over 16, or 5/2. We got all of the answers we were looking for. So over here, replace the a with -1, b with 1/2, c with 5/2, and you're done. So I would say it's pretty straightforward. This methodology can easily give you the answer in no time, everybody. Now, which method is easier for you and you're going to use, ultimately, it's up to you. Nobody's going to ask you what method, just you want to come up with these numbers. That's the idea, A, B, C, when you decompose. So, to recap, you factor this completely. And this is case number one, where every factor is linear and nothing is being repeated. Then you say this can be decomposed into A over X, B over X plus 2, C over 3X minus 2. Sometimes they say A1, A2, A3, it doesn't matter. What about other cases? Case number two, I'll explain the cases and we look at examples. Q of X, the denominator, is a product of linear factors, some of which are repeated. Previously, nothing was repeated. So if that is the case, for example, this one being repeated to the power of 2 or even to the power of r. Here's an example. 3x plus 1 over x minus 1 squared over x minus 2. You write it a over x minus 1 plus b over x minus 2, 1 squared. If you have more, you put c over x minus 1 cubed and so forth. You don't have it anymore. So x minus 2, c over x minus 2. If you work it out, you get minus 7 over x minus 1 minus 4 over x minus 1 squared and plus 7 over x minus 2. So this is case number two. Case number two, we have repeated factors. So in other words, in this case, x minus 1 had an exponent. Case number three, Q of X contains irreducible quadratic factors, none of which is repeated. Take a look. Ax plus b over x squared plus bx plus c. Okay. Q has some irreducible quadratic factor. What do we mean by that? Here's an example. As you can see, x squared plus 1 can't be factored out. That's why it's called irreducible. So what do we do? Well, the factors are x minus 1 and x squared plus 1. So this is just as before, a over x minus 1. But this can't be reduced. So you put it there at the bottom. Because this has degree 2, the top has to have degree 1, bx plus c. And then you go through the process and you find the a happened to be 3 halves, and then bx plus c, okay, it's minus 3x plus 3. And there is a 1/2 in front of that, by the way, okay? Again, that's just an example, everybody. Case number 4, Q of X contains a repeated irreducible quadratic factor. What if that repeats? Okay, and there's an example here, but pay attention to this one. So if it repeats, you put, in this case, x minus 1 and you come up with the answer. You put x squared plus 1, and over here you put bx plus c, you come up with the answer. And then you have the same thing, the power of 2, and another bx plus c, like b2x plus c2, something like that, and you come up with the answer for that. Let's look at an example. Example 4, write the partial fraction decomposition of x squared plus 2 over x minus 1 times x plus 2 quantity squared. Here's case number 2. Q of x is a product of a linear factor, some of which are repeated. This is being repeated. How do we deal with that? First of all, you have to factor the denominator is in factored form. You don't have to worry about it. So you would write a over x minus 1 b over x plus 2, and because it has a degree 2, one more c over x plus 2 quantity squared. That's the way it's going to work, everybody. So it's pretty straightforward. Let's go through the process. We are going to multiply both sides by x minus 1 times x plus 2 squared. So multiply basically by this. Multiply both sides by this. When you do that, what happens? The left side, so let me write it and then I erase it. So multiply both sides by x minus 1 times x plus 2 squared. So what happens? The left side is x squared plus 2. The right side, a times x plus 2 squared. B times x minus 1, it has only x plus 2, so there's one more. So b times x minus 1 times x plus 2. And then c has x plus 2 squared at the bottom, just x minus 1. And I hope, so we clear our fractions by multiplying by that, and I hope you see from here we go here. It's really very straightforward, everybody. Now, I'll collect like terms, and then I'll show you the easy way that I showed you before too. And that means we are going to work on each piece. This one class is x squared plus 4x plus 4. This one is x squared. And we have minus x plus 2x makes it plus x and minus 2. So for example, if I want to collect terms, for x squared, I have a times x squared, b times x squared. Okay, so let's just multiply them. So this is ax squared. Let's just first write them. Ax squared plus 4ax plus 4a plus bx squared plus bx minus 2b plus cx minus c. Let's just write them. Let's show that to everybody. Let's collect like terms, meaning if I put these two together, I get what? A plus b times x squared. If I put 4ax plus bx plus cx together, I get x times 4a plus b plus c, and then 4a minus 2b and minus c are constant. I put them together. I hope you see that. Okay. What is the coefficient of x squared? 1. So this must equal 1. What is the coefficient of x? This must be 0 because This one has no x. It has, let me just write it, 1x squared plus 0x plus 2. And finally, this is the number or the constant 2. So that must be equal to 2. Now, I'm going to leave it for you to solve this system. By now, you know how to solve it. The easiest way would be to say, for example, here, A is 1 minus B and put it here, or B is 1 minus A and put it here, either way, and here, and solve for one variable. And if you solve it, you get A equals 1/3, B equals 2/3, and C equals -2. Okay, everybody? Now, let me erase my word. So you end up with the following. A is 1/3, so 1/3 over x minus 1. B is 2/3, 2/3 over x plus 2. And C is minus 2 over x plus 2 squared. So what I want to show you, again, I want to show you the easy way out that I did in the previous example. And you can avoid using the system. Again, it's up to you. This is the methodology that most everybody uses. But here's the easy way out. So you go here. Let me put the asterisk next to it. You deal with this guy, okay? And you say, okay, what if I choose, just as an example, if you choose x equals -2, just to give you an example. If I choose x equals -2, this goes to 0. This has b times x minus 1 times x plus 2. This goes to 0. So let me show you what happens. So if you choose x equals -2, this goes to 0. This goes to 0. And the left side is -2 squared plus 2. And the right side is c times x -2 minus. That's what you get. So -2 squared is 4 plus 2. So you have 6 equals -3c. And I hope you see that from here, you can get c equals -2. So you see how fast you can get that? So c equals -2. If you choose x equals 1, and I'm going to leave it for you to finish it. If you choose x equals 1, this goes away. This goes away. This is very fast. Let's actually do that. Let me. If you choose x equals 1, this becomes 0, this becomes 0. So if you put 1 here, 1 squared is 1 and 2 is 3. This one you put 1, 1 and 2 is 3, 3 squared is 9. 9a, everybody. 3 is 9a. What is a? 1/3. And by the way, Here's the interesting part. You might say, okay, there is nothing else I can set equal to 0 to find the missing b. Now that you have a and c, you can choose x to be any number. Replace the a with 1/3, replace the c with -2, and then choose x to be any number. The easiest number would be 0, and you can find b. Okay, this methodology class works always. It, at the very least, it can reduce the number of steps you have to take. Okay, you're going to move on. So this was case number 2. Use partial fraction to decompose 2x² minus x plus 4 over x³ plus 4x. This is case number 3, where q of x, the denominator, contains irreducible quadratic factors, none of which is repeated. As you can see, we can factor this into x times x² plus 4. Therefore, this is a over x and bx plus c over x² plus 4. Because this is degree 2 class, you have to put degree 1 at top, okay? Again, this can't be factored. This can't be factored. So you put the first degree up here, bx plus c. And so let's multiply both sides by this. If you multiply both sides by x times x² plus 4, the left side becomes the numerator, the right side, a times x² plus 4 plus bx plus c times x. Okay, it's very simple, everybody. If you want to go with the system, you can. This is ax². Let's just write this one so it makes it easy. So this one is bx² plus cx. So therefore, ax² and bx² is a plus b times x². Then you have cx and you have 4a. It's actually very simple because the system will be solved in no time. X², what is the coefficient? Coefficient is 2. So this must be 2. A plus B is 2. C must be -1. 4A must be 4. So that's really simple. There's really not much you have to do. So C is given. This one says A is 1. Put it here. B becomes 1, 2. Therefore, this expression becomes a over x, that means 1 over x, plus bx plus c, that means 1 times x minus 1 over x² plus 4. So it's extremely simple, everybody. A quick recap. Case number 3. When we factor the denominator, it has a factor of degree 2. That's the bottom. That cannot be factored. Okay, as a factor of degree 2 that cannot be factored. That's the idea behind this. Case number 4, Q of x contains a repeated irreducible quadratic factor. It's just the same as the previous page, but this part has an exponent itself. So again, it's given in a factored form. How do you deal with that? You put a over x, bx plus c over x squared plus 1, and another bx plus c, but with different b's and c's, dx and e. Because this has exponent 2, we need it. If it has exponent 3, we need one more fx plus g over x squared plus 1 quantity cubed. Okay. Now multiply both sides by this. Let's multiply both sides by x times x squared plus 1 squared. And when we do that, this one goes away. The left side is just this, the numerator. And the numerator, I like to write it in descending order. Minus x cubed plus 2x squared minus x plus 1. So we just get the numerator, but in descending order. This one, the x goes away, a times x squared plus 1 squared. This one, x squared plus 1 of them goes away. So it's bx plus c times x squared plus 1. And this one, this goes away, just x is left. So dx plus e times x. This one, we want to take it to the power of 2, becomes x to the power of 4 plus 2x squared plus 1. This 3, when we multiply it, okay, we get b x times x squared, that means b times x to the power of 4, and then b times x 1 and x squared, c times x cubed, and c times x times 1, and this one is d x squared plus ex. So just multiply them through. That's all I'm saying, class. Multiply them through. Now we're going to collect like terms, and we're going to see what is going on. So anything involving x to the power of 4, it's just a plus b times x to the power of 4. Anything involving cubed is just cx cubed. They come together. Now x squared. Let me erase my work and use a red marker. So I'm interested in x squared. X squared. X squared. I want to collect terms. So I need 2a, I need b, and I need d. 2a plus b plus d times x squared. Now for x, I just have cx and ex, c plus e times x. And the only constant is a times 1. So in short, you should be able to go from here to here by noticing you want to collect terms involving x to the power of 4, x to the power of 3, x to the power of 2, and x, okay? I hope that's clear to everybody. So what do? We are going to look at this one. I want you to look at this one, everybody. And look at this one. We're going to concentrate on x to the power of 4. What happens to x to the power of 4? This guy doesn't have x to the power of 4. So what does it have? It has 0 x to the power of 4. So that means a plus b. Let me just write that. A plus b must be what? 0. That's the meaning of it. X cubed. Take a look, everybody. Let me use a different color. That means c must be -1. X squared means 2a plus b plus d must be 2. Look at x. C plus e must be -1 because the coefficient of x is -1. And finally, 1 is the same as a. So that's what you write. Now, this system actually is very easy to solve. So I'm going to quickly show you. It doesn't take long. You don't have to do much because it's mostly solved for you. So first, a is 1, c is -1. That's given. And let me erase my work. So again, a is 1, c is -1. So class, if a is 1, put it here. 1 plus what number is 0? -1. So b becomes -1. So you have a. Now you have b is -1. You have c. So you have a and b. You can find d. And by the way, c plus e is -1. It makes e 0, right? C is -1, makes e 0. Put it here, 2a, 2 times 1 is 2, plus b, -1. 2 and -1 becomes 1, subtracted from 2, and d becomes 1. And now replace it here. A over x, 1 over x, minus x minus 1 over x squared plus 1, and x over x squared plus 1 because a, b, c, d. And I'm going to look at one more question again quickly to remind you of everything we've done. So we've looked at various cases. And here's the last question, everybody. Right, the partial fraction decomposition of this expression 7x plus 1 over x squared plus x minus 6. First thing first, you're going to factor the denominator into x plus 3x minus 2. That's very simple. Then you're going to write this as a over x plus 3 plus b over x minus 2. And now we're going to multiply both sides by LCD, which is x plus 3x minus 2. The result is the left side becomes the numerator only, right? and the right side becomes a times x minus 2 plus b times x plus 3. Now, please understand that we have ax and bx, so a plus b times x. We have minus 2a and 3b. And so a plus b must be 7, minus 2a plus 3b must be 1. So equate coefficients of like powers of x to get. So this, everybody is equal to 7. And this, everybody is equal to a constant. And you can solve it. You end up with a equals 4, b equals 3. And I'm going to quickly show you the easy way out that you don't even need the system. But when you solve that, then 7x plus 1 over x squared plus x minus 6 becomes 4 over x plus 3 plus 3 over x minus 2. I'm going to show you how fast you can solve this without the system. So I'm going to look at this part and say, you know what? If I choose x equals 2, if I choose x equals 2, this goes to 0. 2 times 7, 14 plus 1 is 15, and 2 and 3 is 5. So I get 15 equals 5b, and therefore b equals 5. So I'm going to quickly recap that for you. So I'm going to replace the x with 2. When I do that, this goes away. This 2 times 7, 14 and 1 is 15. This 1, 2 and 3, 5b, b is 5. Now go back to this, and this time I'm going to get rid of this by choosing x equals minus 3. Do you see that? So if I put minus 3 here, minus 3 times 7 is minus 21, plus 1 is minus 20. And if I put minus 3 here, I get minus 5. A, and I hope you see that if you solve for A, you get 4. It comes up with the answer extremely fast with this methodology.